Very good morning to all our present over here. Today I am going to share about the master of principles input process industries. First of all, I am Dr. M. Luisin, Associate Professor, Department of Technology, Excel Engineering College. What's the main theme of from this master of operations means? So, a lot of master of operations we can place it in our processing, chemical engineering operations. Any product formulations, any extraction process, any product recovery, you can utilize only for the mass operations, mass principles. It's like that. Today we will discuss further food process. This is what are the base principles followed in mass operations. So first of all, you can do that. What are the course content in this seminar we will take from that range? First of all, let's say introduction of mass operations, then applications in process industry, principles of division, mode of mass operations, classifications and examples in mass operations, and how we can execute in our mass principles in our research and field. How we can do that outcome from that. So that's why we are going to do from today. Discuss in our sessions. So introduction. So mass transfer is one of the very important one for in our processing field because of any product formulations. Mass is very important. So one mass to another mass, it will be one concentration to another concentration will change. That's only we can make some products. That's why we can go up from that. First of all, so net movement of mass from homogeneous to another. This is mass transfer. Net movement of mass from homogeneous to another. A region of higher concentration to the lower concentration of in our mass due to the driving force, like that concentration gradient. Concentration gradient. These are only for the changes occurring in our any components, any raw materials to convert the product. These are the from these two concepts we can change from that. Okay, so based on difference in vapor pressure and solubility diffusivity, so equilibrium is reached when the gradient is zero. So there is no any mass transfer operations movement one component to another component. It's a stable one. It is a stable equilibrium. There is no any attraction force between from these two any component. It's an equilibrium reached. Okay, at the specific condition of from the temperature and pressure. Okay, this is for that equilibrium, like that we can make to attain the equilibrium level. This transport mechanism is known as mass transfer. It is belongs to physical or irreversible process occurring in this mass transfer operations. Here, mass transfer operations in process industry are followed different variety of operations are there. First of all, for that absorption. So absorption. So any solute present in our any gas mixes. So by using of separate and from the gaseous component, with the help of solvent, it's absorption. We can realize some other process in our processing and our distillations. We can separate any component. You can separate any component with the help of relative volatility as well as boiling point of from the specific component. We can separate from them. Okay, then drying operations. So mostly we can utilize it only for the drying operations. After completion of any product formulations, we can make from the drying operations. We can remove that moisture content. We can maintain the moisture content. Okay, we can maintain the moisture content because now for food field we are replacing for that. We are taking for that food materials. This is only crispy nature. Okay, you have we need to 10% of moisture content. We need to 15% of moisture content. So we can maintain this respect to temperature. So that's why we are utilizing for the drying operations. Then evaporation process. So any you can take for that formulation of high concentrated one. So for that time we can utilize evaporation process. For example, we will make for that enhance the concentration of sugar solution. Okay, we can enhance the concentration of sugar solutions. It will help to enhance the taste of in our product. That's why we are going to take for the evaporation process. Okay, then next one for the humidification and dehumidification process. It is a so any moisture can add based on the atmospheric conditions. So we need to remove that moisture content. We can remove the heat. For that we can utilize for the humidification operation. For example, coolers, air coolers. Okay, so for the dry gas, we can insert in our dryers. So what's the current present? By using a humidification method, humidity chart we can utilize. Like humidity chart. Here we can predict a lot of values. What are the properties of from that dry gas? So this is one of the inlet for the, in our drying operations. That's why we are going to from here calculate from that. Then extraction process. Extraction is one of the most important because of any additives preparations, additive separations to enhance the concentrations. Any product formulation, drugs formulations, you can utilize only for the extraction process. For example, 1000 kg of raw materials will be there, means it will be present for the 100 kg of product, either drugs or some other ingredients. Okay, we can separate by utilizing of solvent. The main application of our extraction process. Then crystallization process. So crystallization is one of the unit operations. It is also utilized for that to form the crystal. So nowadays a lot of products will be there. What we are going to do for that, to make the crystal formation, small particles. We can convert from that based on our requirement. It's a crystallization operation. We can utilize it forward in our food processing field. Okay. Then leaching operations. So leaching is something more. We can separate any solute from solid. We can separate any solute from solid in our food materials. For example, we will take for that extract icosanoic in our solid content present tea powder. So that's why we are going to utilize it in the leaching operations. Here you can utilize for that solvent as a solvent as a milk or water. Okay, it's a leaching operations. Then adsorption. So absorption is the major operations for that. We can recover that solid from either gas or liquid or solid by utilizing of adsorbent. So these are all the examples in our mass transfer operations. We can utilize it in our processing industries. Our processing industry means processing field, preservation field, processing and operations as well as chemical engineering fields. So any this kind of operations we need, which we can follow only for mass transfer principles. Here, first of all, so what is the very base principle of mass transfer operations? First of all, so here in this division, so very base from that in the mass transfer operations. So division is the most important. It means that the movement under the influence of physical changes of an individual component through the mixer. So component has different concentration gradient. That's why it will move from that. Okay. So for example, removal of ammonia by gas absorption. So removal of ammonia by gas absorption from in our atmospheric air or outlet air in our industry. Okay. So we can remove that. Okay, by utilizing of absorbent as a solvent. Okay. Here, very base law from the principle of in our mass transfer operations, fixed law of diffusion. Fixed law of diffusion. So J JA is equal to minus PV dou CA by dP. Is a molar flux is directly proportional to the concentration gradient. Molar flux is directly proportional to the concentration gradient. It is known as fixed law of diffusion. It is a base law of in our mass transfer operations. Okay. Then it is also, it will occurring for that way of two modes will be there. Okay, so only for that. So all the mass transfer operations are unit operation. It occurs through two modes like that. Diffusional mass transfer and another one is conventional mass transfer. So diffusional mass transfer means there is no any external forces we can utilize from that. Okay, so only for that the movement of molecules from so natural way. So for example of here it's a molecular division. So it is a natural division from that. Then so another one is for that steady or convective diffusion. Steady means we can utilize some other forces. We can utilize some other forces. So it will be leads to enhance the concentration to attain the equilibrium. Okay. So that's why we can utilize it for that steady or convective diffusion. We can utilize some external forces. Okay. So for example, we can utilize agitation. That's why we will make the proper mixing up in our liquid mixes, in our food products. Okay, it's a difference from these two. Okay, we can replace it by two. There are two modes will be the divisional modes. First one molecular division. There is no any additional forces we can utilize in our process. It's a molecular diffusion. So another one is we can utilize some other forces. For example, we can utilize agitator. So what's the purpose of agitation? We can add to formulate the homogeneous formulations one in our products. That's why we can utilize secondary way of mass transfer like ADR conductive diffusion. Okay, mostly we are replacing from these two concepts in our mass transfer operations. Then it's a ADR molecular diffusion from that. So for example of molecular diffusions, so one drop of color solution, okay, we will take for that solvent in our own beakers. So we can add one drop of color solution. What it will happen to distribute in our diffuse in our color solution into a lower concentrated solvent. Okay, so in our high concentrated means it's a color solution. Okay, it will be dispersed in our lower concentration having solvent. It's a diffusion. So it will take some time because there is no any there is any disturbance given into the in our system. Okay, that's why it will take some time, but after some time it will make the to attain the equilibrium. There is no any interaction between the color solution as well as in our inner solvent. It is a equilibrium. So end up in our mass transfer operations. It's a molecular diffusion. It's a example from that. Then so conductive or eddy diffusion example from that. So conductive means we can introduce some forces. Okay, so in our proper mixing operations, so for example, you take a cup of coffee. Okay, we need to taste in our sugar content. Okay, we can add our sugar content. So automatically it will not dissolve or dispersed in our all the tea like that. Okay, but so we need to dissolve from the sugar content. So we can utilize for that stirrer, so agitator like that. Okay, you can utilize spoon. It is a convective mode. We can make it to enhance the dissolve in our sugar in our tea. That's why we can go for the convective or eddy diffusion from that. Okay, it will reduce the in our to occur the mass transfer operations. This is one of the it's a difference for that. So molecular and eddy diffusion. So molecular diffusion means it will take some time to attain the equilibrium. So eddy diffusion it will make for stirring process. So it will be easily attained for the equilibrium. That's why we can utilize it eddy diffusion because it will reduce the process time, operation time. So the difference from these two division of mass transfer operations. So after completion of diffusion is like that. So end up in our product. So classification of mass transfer operations. Here in this mass transfer operations we can classify on there are three categories. First one for the gas liquid operations. Next one liquid operations. Then fluid solid operations. So gas liquid operations means so liquid dispersed into the form of discontinuous film in a continuous gas phase. For example, we can utilize this spray tower, packed tower, Venturi scrubbers. Okay, so here we can, for example, we can separate in our gaseous solute from in our gas mixer by utilizing of some solvent. That's why we are utilizing for the gas liquid operations. For example, gas liquid operations we can classify so absorption, desorption, humidification, dehumidification, and distillation operations. We are utilizing in our mass transfer operations to make some applications in our processing field. Then liquid operations. Here only we can utilize it for the extraction process. So extraction means you know that. So only you can extract any component in our liquid mixtures by utilizing of solvent. It's an extraction. Okay. Here for example up here acetic acid from acetic acid water mixtures using isopropyl ether as a solvent. This is one of the extraction process. Here we can utilize isopropyl ether. We can recover in our acetic acid. For example, from that. So same thing in our food field also we can utilize it for that. We can recover any additive components from raw materials, any fruits. Okay, we can separate by utilizing of some water. Okay, it will be dissolved from that. We can recover from in our product. For example, we can make for that Dickerson, he concentrated one. So for the time we can place liquid extraction operations. Then fluid solid operations. So one of the most important operations for in our processing field as well as preservations like that in our chemical engineering field also they are replacing